So this is the first problem of today's div 2, and in this problem we're given that a positive integer is called k beautiful if the digit sum of the decimal representation of this number is divisible by k. So, and we just have to find, like we're given two integers x and k, and we just have to find the smallest integer y, which is more than or equals to x, which is k beautiful. So if we look at the constraints, k is less than 10. So what we can do, we can simply brute force our solution. So while the loop is true, we'll keep doing x plus, like we'll check for x whether this is like the digit sum of this number is divisible by k or not. If it is, then we have found our answer. Otherwise, we'll keep doing x plus plus. Why? Because since k is very small number, so eventually we'll find it in 10 steps. Is it clear to everyone? Like 10 or 20 steps. So let me show you the implementation. So this is the implementation. In this, I have first taken x and k as input. Then while this loop will run, I'll first initialize, like make this sum as 0, and this is my temporary variable which is holding value of x. So using this temporary variable, I'll find the sum of the digits, and if it's divisible by k, I'll print this x and I'll break this loop. Otherwise, if this is not true, then I'll simply increment my x for the next iteration. So I hope this is clear. So going to the next problem. In this problem, we are given that we have a binary representation consisting of n bits, possibly with leading zeros, and we just have to find that what is the minimum number of swaps. If like we can swap any two adjacent bits, what is the minimum number of swaps such that the number is divisible by 2 to the power I, and we need to do this for every I from 1 to n. So see, if your number needs to be divisible by 2 to the power 1, I is 1, then you should have something like you can have anything here, but the last thing is that after this point, after I, you should have zeros only, right? Because if you have any 1 here, let's say you are trying to divide by 2 to the power I. So if you have any ones in the binary part of like binary representation, if you have in the binary representation of n, you have any ones in this part, this won't be divisible by 2 to the power I. There will be eventually something will be left out as the remainder, right? Everyone is clear up till this thing? Like this is 0th bit, first bit, second bit, third bit, up till all the way this. So if I want my number to be divisible by I, everything after this point should be 0. So you just have to see one thing. If you have this as your current number, you like start iterating from here. If you find that there is a 1, you need to like bring this 1 to any of the zeros on the left side. Now, what is the best optimal? Like what is the best case scenario? That you bring this 1 to the closest 0, right? Because you have to minimize the number of swaps. So just bring this 1 to the closest 0. So that is here. Then on the next iteration, when you come here, you again find that, okay, this position is having 1. So again, shift this 1 to the closest 0, that is here. And this is your number of swaps, by the way. So how to, first of all, how to find this? This can be done like either using a vector or a set or anything. Like you can find the left, like what is the 0, which is closest to the left of this 1. If there is no 0, then your answer is simply -1. You cannot shift this one anywhere. Otherwise, you can shift this one, right? And now the point is, see, if you have something like this, and we brought this one here, and then on the next time we'll bring this one here. So you might think that this is unoptimal. We should bring this here and bring this one here, but the number of operations will be like the number of swaps will be same only. If you do it like this also, like first bring this one here and then bring this one here. So that's why the above approach works. Like just see that if you have a 1, shift it to the closest 0. Like the place which is having the closest, which is closest and having a 0. Is it clear?
Bhaiya, can you quickly repeat once from starting?
Like have you joined late?
Yes, yes.
Okay, so first problem will be clear, right?
Yeah,
Just the
yeah.
second
First
one.
problem will be
Okay.
clear.
So
I
in
will
this
start.
problem, we are given like we have some binary representation, and we just need to check like for each I from 1 to n to like it should be divisible by 2 to the power I, right? So if a number should be divisible by 2 to the power I, the last I bits in your number should be all zero. Why? If they are not zero, if any of these are having a one, then eventually it won't be divisible by 2 to the power I because there will be some remainder left. Is this thing clear?
Yes, yes.
Now, in order to bring this one to any of the zeros, like you want to bring like since I'm currently checking for 2 to the power I and I found that here there is a 1. So I need to bring this one to any of the like some zero I want to swap it with, right? So find the closest zero that is available to you on the left side. So this can be done either via vector or a set or anything. But the thing is, you just have to bring this one, like you have to swap this one with the zero, which is closest to you right now.
Can
And
I ask?
this zero will come here and this one will go here. Is it making sense?
So can I ask one thing?
Yes, yes, yes.
So like for the binary representation of a number, if I is like for example, if 2 raised to power 4, right?
Okay.
And there is a number, any number, x number. So I have taken the binary of that number and want to check that 2 ki power 4, that number is divisible by 2 ki power 4, right?
Yes.
So I will check that number binary representation, the ith bit, like 4, the
Like
fourth
yes, fourth, like last four bits should be zero.
last 4 would be 0. If that is not 0, then it would not be divisible.
Yes.
Then I need to check that how much swaps is required to make it divisible, right?
Yes.
Okay. So if I put from 1 to 0 in fourth bit, then only one swap is required.
Like
Like,
one swap is required if there is only there is a one and zero is very like you cannot swap any bits like any you can swap only adjacent bits.
And yeah, and at the from at like ith bit till n bit, every number should be divisible with that number, like 2 ki power I.
Yes, you have to check
All
for
ones.
every I. You have to check for every I from 1 to n. Like you have to do this for every I between 1 to n, and you have to print answer for each of these. So basically you should start from here I from 1 and then you should go till this side. So if you are at this I, you have already made sure that whether like if this part itself wasn't divisible, then if like for this part your answer was -1, then for this part also your answer will be -1. But if you already have some answer for this, like you have some number of swaps and you find that here you have 1. So again, you'll try to shift this one to the closest 0. Like you'll try to swap these two. What are the number of operations? Let's say like in this case, this 0 is here, there is one element in this thing. So the number of swaps would be, if let's say this is j, the number of swaps would be I minus j. The lattice in this case, this is 2 swap. Why? First you will swap these two, then you will swap these two. So eventually 0 will come to here, right? Yes. Okay. Is this clear to everyone? Okay, so let me show you the implementation. So in this, I am using a set. You can do this using a vector also. So I have inserted all the positions in my set, which are 0. And then I'm starting from the last place, like I said. Please don't annotate the screen. Who has done this?
sorry, I did.
Yes, so remove it.
Okay, I remove it. Okay.
So I'm starting from the last index and I'm going till 0. And if the current place is having a 1, then I simply check if the answer is -1. That it means that the for the last I also I couldn't divide it, or I don't have any zeros left. So I cannot swap this one, right? I cannot have a 0 at this place. That's why my answer will be -1 only. Otherwise, I'll try to swap this ith one with the closest 0. So that is the why I'm doing the R begin will give me the maximum j. So maximum j simply means which is closest to I, right? So the maximum j. So after this point, make sure that at this place now you have a 1. You need to do this also. After this, just make sure that you remove this 0. Like earlier you were having a 0 at this place, now you're not having a 0 there, so removing it from here. So this is the case when you have a 1 at your current place. Otherwise, if you are having a current place, you're having a 0, just check that if this position was in your set. If it is in your set, remove it from your set. Finally, for each I, you can print your answer like this. Is it clear?
Yes.
Okay, so let's go to the next problem. So in the next problem, we are given that we have an array A, like of m integers. Initially, everything is 0, and then we are given some Li to Ri, like some distinct n pairwise distinct segments. And what we can do, we can select a subset of these segments, and we can add 1 to each of these. Like once we add 1 to each of these, we have to find this thing, like we have to maximize this thing, that is the maximum value present in array A and the minimum value present in array. So if we first of all look, what is the size of array possible? It is 10 to the power 9. So we won't make that array, okay? And the segments are this thing. So let me give you an idea. See, we have an, let's say these are these m elements, and then we are given different like ranges. We have to select some ranges out of these, and in those ranges we will add 1. Let's say if I select this range, I will have 1, 1, 1, 1 added here. If I select this range, I will have 1, 1, 1, 1, 1 added here. So after this operation, you will see that in these two places I have 2, and in every other place I have 1. So the maximum minus minimum is 2 minus 1, which is 1, right? So I have to maximize this thing. Now tell me one thing. Is there, like, do you get any benefit in applying operation from 1 to m? Do you get any benefit? Like if you are applying this kind of operation, like this is your segment, you're adding 1 to each value from 1 to m. So maximum will also get increased by 1 and minimum will also get increased by 1. So what's the point of these kinds of operation? So the point is, you will either apply operations, like leave this one out, you'll apply all your operations on this part, like all these segments which are strictly in this part, don't apply operations on the first place. And this will ensure, like this will make sure that your minimum is always this thing only. Like this will have 0. You are not applying any operation like which is covering this first index. So this is your first scenario, and the second scenario is don't apply operations on the last item, like the last index. So every operation that was ending at the last place, it can be anywhere like this. Don't apply operation on this. You won't have these kinds of segments. Apply every operation which lies completely here. So the maximum number of overlapping segments that you get here, number of overlapping segments, So, and the maximum number of overlapping segments, the maximum of these two is your answer. Why? See, the number of overlapping segments in this part simply means that the maximum value that you will get in this part, right? Because each segment is adding 1. And this place will eventually have 0 only. So maximum minus minimum is nothing but the maximum number of segments that have overlapped in this part. Similarly, maximum minus minimum in this will be the maximum number of segments that have overlapped in this part, right?
सर समझ में नहीं आया, दोबारा एक्सप्लेन कर दीजिए इस course को.
See, there is no point. See, if you have to have, you can look at it like this also. See, you have to do maximum minus minimum, right? So let's try to make the minimum element always 0 only. Why? Because if you're having any, let's say you're having 3 segments which covered this minimum also. So what is the best case? That they were covering this maximum also. Otherwise, if they were not covering this maximum, then what was the point of taking them? So they were covering this maximum also. So, but this is same as not taking those 3 segments. Then also maximum minus minimum will remain same. So the point is that your minimum value can always be 0. Like there is a solution in which your minimum is always 0, right? So now if your minimum is always 0, what you can do, as we've already seen that there is no point in taking a full segment like from 1 to m, you can either always leave this first place or the last place. Like there's a solution, like there is the optimal solution consists
तो
of a
हमें मतलब ये अज्यूम करेंगे हम फर्स्ट और लास्ट को लिए, पर मतलब क्या पता कोई बीच में कोई हो पर्टिकुलर
yes,
इंडेक्स जहाँ पे ना ओवरलैप कर रहा हो, मतलब आप फर्स्ट और लास्ट को
overlap,
क्यों ले रहे हैं?
overlap. They like in middle they are overlapping or they are not overlapping.
हाँ, जैसे कि फर्स्ट से थर्ड हो और फोर्थ से फिफ्थ हो, नहीं से फर्स्ट से सेकंड हो और थर्ड से फोर्थ से फिफ्थ हो, तो सेकंड थर्ड वाला इंडेक्स रह गया ना, मतलब वो वन
So
से
what
थ्री
is
ना
the
हो।
answer in this case? What is the answer in this case?
मतलब जैसे आपने बोला कि स्टार्टिंग और एंड में हम मानते हैं कि
It is okay,
ओवरलैप
but
नहीं हो
what
रहा
is
है,
the answer in this case? What is the answer in
मतलब
this?
आंसर तो हाँ बन ही आएगा, वन वन माइनस जीरो।
So it could have been if you left out this and you would have taken minimum from this and maximum part
बट
from
सर ये हम प्रूव कैसे करेंगे कि हमको लास्ट में ही छोड़ना है, लास्ट फर्स्ट और लास्ट ही छोड़ना है,
no,
क्योंकि मतलब ये तो
the
मतलब
proof
ये
is
चीज क्यों मतलब हाँ।
that see minimum will always be 0, right? So if you're taking anything from here, this simply means that you're either having answer in this part, you're having the maximum in this part or this part, right? So if you're looking answer for in this part, try to maximize this range, shift this element to the last index. So you are getting the bigger range only, right? Now you're seeing all the segments which lie in this range. If you are having this as your like minimum, then what what are all the places that you are see? If you're having some place in middle, you say that this will be your minimum. So this is equals to 0. So there is no segment that is going over this, right? There are some segments in this part and there are some segments in this part, right? Now tell me one thing. You will be looking for in this range, you will be looking what is the maximum number of overlapping segments, right? And in this range also you will look the same thing, that what is the maximum number of overlapping segments, and you can do this for each and every eye. But tell me what is the most optimal, what is the biggest, like if you have bigger range, then you can have more segments overlapping maybe. So there is two things, either shift this to the first index, this the minimum thing, or shift this to the last index. Then you will have this part, find all those like segments which are in this range, completely in this range, and find the maximum number of overlapping segments in this part. Do with the same thing with this part, that all the segments are in this part. Do you get my point? Like you're doing the same thing for here also. If the minimum is this, the value will be 0. You get my point?
यस।
What about others?
बट जैसे हमें नॉट टेक एंड नॉट टेक दिया था, तो इसका जैसे कि जो डीपी अप्रोच होती है टेक एंड नॉट टेक वाली, वैसा कुछ प्रिडिक्शन नहीं हो सकता ऐसा इम्प्लीमेंटेशन वैसा,
What?
जैसे टेक और नॉट टेक वाला जो अप्रोच रहता है?
No. Like that will have, like you can share your code once with me, but that will I don't think like the time complexity
सर
will.
मेरा कोड वो एक्सेप्ट नहीं हुआ।
No, but still I'll try to help you understand why that didn't get accepted.
ओके सर, मैं डाउट में डाल दूंगा वो
Yes,
डेली के।
sure. But this is clear to everyone, right? Okay. So now it is just implementation. How will you find the maximum number of overlapping segments, like not considering all the segments which started here, all the segments that are going on like this? How will you find the maximum number of segments? So what we can do, we cannot make an array like opening and closing, because the segments, like the range over which the segments are swapping, are very big. So what we can do, we can just simply find, like here one segment started. So for each place when a segment is starting, we'll have an ongoing variable and we'll increment it by 1. And for all of these places, like here, my ongoing will decrease by 1. Here, my ongoing will decrease by 1. So either you can go through each of these discrete points, like where a segment is starting or where a segment is closing. Or you can also do one thing, that only go over those points where your segments are starting. Because see, when you come to this point, you will see, when you come to this point, okay, nothing closed. But when you come to this, you see that, okay, one segment has closed. So you can maybe implement it using a set, that how many segments have closed before this point. This set will be having only closing points, like where your where are your segments closing. So you can find where did your segments close, and you can decrease your ongoing by that much amount. Or you can just iterate over all of these opening and closing points. Like where you are opening, just increment by 1. Where you are closing, just decrement by 1. So this is just the simple implementation, and answer is nothing but the maximum of this ongoing. How many segments are opened at once? If there are 3 segments open in this range, then you will have a value of 3 in your array. And minimum is always 0. So let me show you the code. So this is the case when I'm removing 1. So like I won't include 1, like any segment which is going over 1. So first of all, this is like the places at which my the segments are closing. How many segments will be closing at ith place? This will hold that. This is the ongoing variable, and this is the set basically. Before this place, how many places my segments have closed, have ended. So I'm going through my segments. I have sorted them in increasing order. So if my first segment, like if the starting point of this segment is 1, I'll simply continue. I won't consider this. Like I won't take this segment basically. Otherwise, for the ith place, I'm first checking how many segments have closed before this point. So I'm going to decrease the number of segments which closed at this point, and I'm going to remove that point from my set. Then, since there is a segment opening at this point, I'll increment my ongoing by 1s, and then this segment will close at this point, and this point I'm inserting in my set also. And why am I increasing by 1? Because it is still like the segment is still contributing to this place, but it won't be contributing to +1. So that's why I have done this. Then my answer is nothing but answer is maximum of answer and ongoing. So then I'll clear my set. I'll make my ongoing 0, and I'll clear my map. Then this is just for making, like, initially I have sorted according to the first value, like opening points. Then I'm sorting according to my second, that is the closing points. So doing the same thing for this thing, like I won't consider all the segments that are swapping this point. So all the segments like this, I'll consider these segments. So for this, I have sorted my segments according to the end, like their ending points, and I'm doing the same thing again. Just iterate in reverse order. If the segment is closing at M, don't skip it. Otherwise, find how many segments have closed. Like not closed, this will be like, if this was closed, like this was closed, this is opening. So technically, like how many segments have ended before, if I'm currently here, if I'm currently somewhere here, so how many segments have like ended? So removing those segments, decreasing my ongoing by that amount. Then since there is a new segment that is like that'll this segment, it won't start from here, but this segment is like the starting point will be somewhere here, but this segment is now contributing the value, right? So that's why ongoing will increase by 1. This segment will end at this point, inserting the value at this set. And again, my answer is maximum of answer and ongoing. Is it clear? So this is clear to everyone, right? Can someone unmute and tell me whether? Yes, bhaiya, it's clear. Okay, you are writing in the chat. Yep, it's clear. Okay. So let's go to the next problem. So this is the next problem, and in this problem we are given that we have an array A of n integers and a pair of integers ij such that I is less than j is called good if there does not exist any k between 1 to n which divides both ai and aj. So we have to count the number of good pairs. So the thing is that array A itself, like the elements are between 1 to n only, right? So we have to count I and j such that there is no k which divides both ai and aj. We have to find this kind of pairs, right? So see, first of all, if the array elements are between 1 to n only, what are we actually finding? See, what are the total number of pairs? First of all, I and j such that I is less than j. Like instead of finding all of these pairs, we'll try to remove those pairs which have a divisor. So what are the total number of pairs? If there are n elements, we have n into n minus 1 by 2. Is anyone having any doubt in this part? Like the total number of pairs will be n into n minus 1 by 2.
No, bhaiya.
Now we have to remove, we need to remove I and j which have a divisor, right? So see,
What is the formula? N into n minus 1 by 2 means.
number of ways of selecting any two integers, nc2. Like this is the total number of pairs that you can get. Is it clear?
Yes.
Okay. So now we need to remove I and j, such pairs I and j which have a divisor present in array A. So first of all, see what we can do. We can count the number of pairs which have GCD as x. Like x will be from 1 to n, right? Once we do this, what we can do, if we just count the number of pairs which are having this as the GCD, so later on, let's say we are able to do this, then later on, how can we use this? We'll go from 1 to n, and if we find that array has the ith element, like array is having the ith element, then for all the multiples, for every multiple of I between 1 to n, we will remove all the pairs. Like let's say this was given to us by count, so we will remove if I is present, we will remove from answer, we will subtract count of this multiple of I. Why? Because I is present in my this element I is present in my array A, and every multiple of I is divisible by I. So every multiple of I, like this was the GCD of pairs, like how many pairs had this as the GCD. Count was giving me that, right? So I'll subtract it from this. And also after this point, I'll make my count of this multiple of I is equals to 0, so that I don't subtract it later. Like 6 is divisible by 2 also and by 3 also. So you don't have to subtract it twice from your answer, right? So this is just for this case when like I have subtracted it once. But for every I, like once we have this thing, that is the count of number of pairs which are having GCD as x. Once we have that thing, the rest is very simple, right? For every I from 1 to n, I is from 1 to n, we will, for every multiple of I, we will do one thing, that will subtract. Answer was initially having all the pairs, that is n into n minus 1 by 2. So from this number, we'll subtract all the pairs which are having GCD as, this is nothing but all the pairs that have GCD as multiple of I. Now tell me what, like only in this part, not in this part, how to calculate this first. Like I'll explain this in a moment, but this part, how many people are still confused in this part? Unmute and let me know. Like how to count this, I'll explain this in a moment. But first of all, like count is nothing but all the pairs that have this count of x is nothing but how many pairs having, all the pairs having x as GCD. Is it making sense? And answer, like from answer, I'll subtract all the number of pairs which have multiple of I as GCD. Why? Because I is present in array. Is it making sense?
Yes, Bhaiya.
Is it clear to everyone? Yes or no?
This part is, I think I need some. Can you repeat? Like every multiple of
Once
I.
you have only this, I'll repeat. Once you have a count array, which will give you the number of pairs which are having, like count of x is nothing but number of pairs which are having x as your GCD. Since answer was initially every number of pair, you'll go from I from 1 to m, and if I is present in your array A, for every multiple of I, you will just decrease your answer with this value. That is number of pairs which are having, like which were having GCD as multiple of I. Why? Because all those pairs are now divisible by this I. Is it clear? Because see, two numbers alpha and beta were having GCD as multiple of I. So both of these numbers are now divisible by I. So if I is present in your array A, these are not good pair. So that's why decrease such number of pairs from your answer. Is it clear now? Yes, no, anything? No.
Yes, Bhaiya.
Okay, so now only this part is left, how to count the number of pairs which have GCDX. So this is a very standard problem. See, if you have to count the number of pairs which have GCD, and this is only applicable for this problem, in which n, like array elements are between 1 to n. Count the number of pairs which have GCD as, the count I is the number of which as I. So how to do this? See, like if you need a knowledge of sieve, like method of sieve for this. So what happens in sieve, we just do something like this, right? For int I is equals to 1, I is less than equals to n I plus plus, and we have another loop which is for int j is equals to 2i, j is less than equals to n, j plus equals to I. And here we can perform our sieve, right? So instead of this, why not start from ending? Like count initially, let's find the frequency of every element, like how many times each element appears in our array. And then what we can do in order to find the GCD, we'll count, like count of I will be first of all, like number of times we have elements which are divisible, like frequency of I will give us the number of elements which are divisible by I.
नहीं भैया ये समझ में नहीं आया.
Like do you know about sieve?
Yes, भैया.
Okay, so if you know about sieve, see, if we have the number of elements, like how many elements are equals to I, what I can do is count all the numbers which are, like count all the numbers which are divisible by I, and then from this remove those numbers which are like whose remove all the pairs which have GCD as 2i, 3i, 4i, 5i, like this. So that will give you, count I will give you all the pairs which are having GCD as I. So this is what we do in sieve also, right?
Yes, भैया. Yes.
So like probably from code you will understand it better. So this is my array A. This won't have the array elements, but this is having the count of number of elements, like number of times it is appearing in my array. So I have this, I am taking x as input. Now x will appear one more time. That's why a of x plus plus, then answer is initially n into n minus 1 by 2. This is the f is nothing but my count, like the number of times I is appearing, like the number of pairs which are having I as the GCD. So m is the total number of elements which are divisible by I, and first of all I'm decreasing all those things like 2i, 3i, 4i, and then finally I'll add this m into m minus 1 by 2. So eventually I'll get that only, the number of pairs which are having GCD as I, and then finally what I can do, going from 1 to n, just check if I is present in your array. AI is nothing but if AI is 0, then it simply means that the ith element is not in your array A. Otherwise, if a of I is more than 0, then it means that this was I is present in your array. So go through all the multiples of I, subtract your answer, like from answer, subtract f of j, that is all the multiples of I, and then make fj 0. Finally, you can print your answer. Is it clear?
Yes, Bhaiya. But the second for loop is actually doing that C part, right?
Yes.
Okay, got it.
And like try to write, like the logic is very like small, but it's very hard to understand if you like blindly look at that. So try to write this thing using the pen and paper, and then you'll understand it. Otherwise, if you see at the logic, like you won't understand it. But like whatever I've explained you, try to write it down on a paper, and then you'll get it.
Yeah,
So,
Bhaiya, sure.
and in case you are stuck, just raise a query and like tag any of the mentors. So that's it. And there is another contest like from 4, I think, from 4:30. So all the best for that. And thanks for
Thank
joining.
you,
Bye-bye.
Bhaiya.